Hello and welcome to this edition of Pain in the Math. Today we're going to study powers and exponents. Our learning targets are going to be, we will define and provide examples of powers, bases, and exponents, and we will evaluate expressions using powers. Okay, we need to go over a little bit of vocabulary. First, we need to talk about what is a base. A base is the number or variable that is used as a factor to be multiplied times itself a certain number of times. In the example here, we have in the expression 3 to the second power, the base is, well, it's the 3. Okay, so let's talk about what's the exponent. The exponent is the number or variable that represents the number of times the base is multiplied by itself. So in the expression 3 to the second power, the exponent is the 2. Finally, what is a power? Power is an expression that consists of a base and an exponent. An example here that we have in the expression 3 to the second power, the power is the entire 3 to the second power. Okay, let's go over some examples of how we apply this. Okay, so it's important to be able to read and write using powers. So what do these powers mean? So in this example, it asks us to express each of the powers in words, then its mathematical operation. And we're also going to provide a solution to this. Okay, this first power that we're getting is 3 to the 0 power. So the word meaning is 3 to the 0th power. Anything to the 0 power is going to be 1. So that's just going to be the rule. Anything to the 0 power is going to equal 1. 0 cannot be put to the 0 power, so that would just be undefined. But anything else, 3 to the 0 power, 7 to the 0 power, 532 to the 0 power, x to the 0 power, all those things will equal 1. Okay, next, let's do our power 10 to the first power. So 10 is our base, 1 is our exponent. So we're just going to write it 10 to the first power. Okay, so here the operation is just simply going to be 10. There's only one 10 there, so we're not really multiplying it times anything. 10 equals 10. So our solution here is 10. Next, we have a base of 4 and a exponent of 2. So we're going to write our base, 4, and we're going to say to the, then we say what the exponent is, well, to the second power. It's pretty common for people to also say the exponent is 2 to say squared. So you could also say 4 squared. Well, the operation here, we're going to have a 4 times a 4. Okay, so a 4 times a 4, that solution is going to be 16. So that second power means there's going to be 2 4s, and they're going to be multiplied times each other. All right, this next one, we have a base of 5 and an exponent of 3. So we're going to write 5, and then we're going to say to the third power. Okay, and whenever you have something to the third power, it's not uncommon for people to say cubed because it's used for measuring volume, for example. But we're going to say 5 to the third power, and the operation is going to mean we have a 5 times a 5 times another 5. So we have 3 5s being multiplied times each other, which gives us a solution of 125. Okay, finally, we have a power with a base of 2 and an exponent of 4. So what will we get here? We'll have 2 to the 4th power. Okay, so 2 to the 4th power, we're going to have 4 2's all multiplied times each other. 2 times 2 times 2 times 2. Okay, so when you multiply 2 times 2 times 2 times 2, you're going to get 16. Okay, so that's how you read and write your powers. So let's go over a few applications. Okay, so we're going to evaluate powers. Example 2 asks us to evaluate the expression x to the third power when x equals 2. What I like to do is just write what they gave me, x to the third power, and then I set it equal to, rewriting it again, except instead of writing x, I just put in 2. So we'll have 2 to the third power. Well, that means we have 3 2's multiplied times itself. 2 times 2 is 4 times another 2 is 8. And that will be our answer. Example 3, evaluate the expression t to the third power when t equals 4. Okay, I'm going to write the expression, and then I'm going to write again, except I'm going to substitute the number 4 for our t. So we'll have 4 to the third power. Okay, 4 to the third power is going to equal 4 times 4 times 4. Okay, and what we'll get when we multiply those together is 64. All right, let's do a few more examples. This time, we'll be evaluating expressions using exponents. So this looks a little more complicated, not too bad. Evaluate each expression when a equals 2 and b equals 3. So I'm going to rewrite the expression. A plus b quantity squared. So the quantity squared means whole things being squared. Then I'm going to rewrite it again. Instead of writing a, I'm going to write 2. Instead of writing b, I'm going to write 3. Okay, using our order of operations, you always do what's in the parentheses first. Well, 2 plus 3 is 5. It'll be 5 squared, which is the same as saying 5 times 5, and we solve that to 25. Okay. Now, for this next example, I'm going to rewrite my expression, a squared plus or b squared. Then I'm going to rewrite it again and just put in the numbers we're given. 2 squared plus our 3 squared. Okay, well, 2 squared is 4, and it's plus 3 squared is 9, because 2 squared is 2 times 2, which equals 4, and 3 squared is 3 times 3, which equals 9. 4 plus 9 gives us a solution of 13. Okay, all right, so we're going to do some mixed expressions next. So here it looks like we have the same problem, except there's only the difference of parentheses. We're asked to evaluate each expression when y equals 3. So again, I'm going to rewrite what they gave me. Then I'm going to rewrite the expression by substituting our 3. So here we're going to have 4 times our y squared. So exponents comes before multiplication in our order of operations. So I'm going to say 4 times our 3 squared. Okay, well, we'll do our exponents next. So we'll have 4 times, since our 3 squared is 3 times 3, that would be like saying 4 times 3 is going to give us 36. And that's our answer. So what will we get with 4y quantity squared? So 4y whole quantity squared, rewrite that. And then I'm just going to rewrite it, substituting our 3. 4 times 3. That whole thing will be squared. Well, 4 times 3 is going to be 12. Okay, that's going to be the same as saying 12 times 12. Well, 12 times 12 is 144. Thank you for watching this episode of Pain in the Math. Here are a few practice problems for you to try on your own. If you would like a printed copy of these practice problems, you can visit me at my Teachers Pay Teachers store in the description below. If you like this video, please like, comment, and subscribe.